Hello guys, welcome back to our channel, and today we are going to discuss buildings that were designed for earthquake proof and show you some of those earthquake proof buildings that was engineered and built. Throughout the history, engineers have built impressive structures and cities only for them to encounter the forces of nature. Earthquakes are one of the Earth's most destructive forces. The seismic waves throughout the ground can destroy buildings, take lives, and cause tremendous amount of money for loss and repair. Over the past few decades, engineers have introduced new designs and building materials to better equip buildings to withstand earthquakes. Earthquake is unlikely we'll ever be able to predict. Scientists have tried many different ways of predicting earthquakes, but none of these have been successful. But in the Philippines, there are a lot of people who can predict the earthquakes and other calamities. We call them the MANGHUHULA, and some of them are very famous. But before we look at these earthquake-proof features of these buildings, we better understand first how earthquakes impact man-made structure. When an earthquake occurs, it sends shockwaves throughout the ground in short, rapid intervals in all different directions. While buildings are generally equipped to handle vertical forces from their weight and gravity, they cannot handle side-to-side forces emitted by these quakes. This horizontal load vibrates walls, floors, columns, beams, and the connectors that hold them together. The difference in movement between the bottom and top of the buildings exerts extreme stress, causing the supporting frame to rupture and the entire structure to collapse. To counter these forces, engineers design an earthquake-proof building and reinforce the structure and counteract an earthquake's forces. Since earthquakes release energy that pushes on building from one direction, the strategy is to have the building push the opposite way.
Methods that engineers used in designing an earthquake-proof building. The first unang method is reinforcing the building's structure. Para hindi mag-collapse, buildings need to redistribute the forces that travel through them during a seismic event o lindol. Shear walls, cross braces, diaphragms, and moment-resisting frames are central to reinforcing a building. Shear walls, o yung mga pader na buhos, are a useful building technology na tumutulong para mag-transfer ng earthquake forces and help a building keep its shape during movement. Diaphragms, o yung mga slab, are a central part of a building's structure. Consisting of the floors of the building, the roof, and the decks placed over them, diaphragms help remove tension from the floor and push force to the vertical structures of the building. Moment-resisting frames provide more flexibility in a building's design. It is placed among the joints of the building, and allows for the columns and biga to bend while the joints remain rigid. Thus, the building is able to resist the larger forces of an earthquake, o lindol, while allowing designers more freedom to arrange building elements. The second na pangalawang method is pendulum power. This is a damping method used primarily sa mga skyscrapers. Engineers suspend a large ball with steel cables with a system of hydraulics at the top of the building. When the building begins to sway, the ball acts as a pendulum and moves sa opposite direction to stabilize the building. Like damping, these features are tuned to match and counteract the building's frequency in the event of an earthquake or lindol. The best example ng ganitong building is the Taipei 101. Taipei 101 is one of the most nakakamanghang skyscraper in the world. It houses the biggest tuned mass damper or TMD in the world. It is basically a supergiant metal ball that counteracts big transient loadings like wind and earthquakes to reduce the galaw of tower. The TMD is supported by hydraulic damper arms and bumper systems, which function like the shock absorber of a car. When large forces act upon the tower, the TMD sways in the opposite direction, bringing the entire building into equilibrium by damping out the transient forces using the ball's mass. The third na pangatlong method is creating a flexible foundation. One way to resist ground forces is to lift, o paangatin yung building's foundation above the earth. Base isolation involves constructing a building on top of flexible pads made of steel, rubber, and lead. When the base moves during lindol, the isolators vibrate while the structure itself remains steady. This effectively helps to absorb seismic waves and prevent them from traveling through a building. The best example of this type of building is the Philippine Arena. The Philippine Arena is the world's largest domed arena with a seating capacity of 55,000, and is an amazing lindol-proof structure. It is also the centerpiece of the tourism enterprise zone called Ciudad de Victoria in Bulacan, Philippines. The Philippine Plate sits along the so-called Pacific Ring of Fire, home of the world's most notorious and active chain of earthquake fault lines. Philippine Arena's vast stadium roof, spanning 170 meters, was engineered to withstand severe transient loadings such as lindol, malakas na hangin, and bagyo. The main structural body of the arena is isolated from its base and foundation, like yung parang manananggal, naka-separate yung katawan sa paa. The gap between the main structure and base foundation system is composed of lead rubber bearings, OLRB, which are a flexible arrangement of materials with high energy dissipation properties. This allows the base and foundation system to freely move habang lumilindol, while the top structure remains stationary.